So, having a test tomorrow. This was supposed to be done last week, but we had a hurricane. And so I decided to not give it last week and kind of forgot about it yesterday. But the test is only going to cover everything before dimensional analysis, and it's mostly going to be significant figures and density. Actually, I look up. So there are 25 questions in total. Eleven questions deal with significant figures. Eleven questions deal with density. 4 questions deal with precision and accuracy. No, it's not. 2 questions deal with intensive, extensive, chemical versus physical. By the way, if you're very observant on how I'm wording this, I clearly stated there's 25 questions. 11 of those questions deal with significant figures. 11 of them deal with density. That is not exclusive. We can have a question deal with both density and significant figures. In fact, there are some overlap between density and significant figures. Not wrong. It's just that some questions deal with both significant figures and density. And we have 2 questions that deal with safety. So yes, if you are observant, this does not add up to 25. It's over 25. That's because some questions deal with both density and significant figures. So you need to know how to properly do significant figures, and you're going to need to memorize the equation for density. Density is equal to mass divided by volume. So let's look at the other few random questions. Safety. For the safety questions, these are approximations also. This is just me quickly going through and counting. For safety, I know they're mostly common sense. I actually think they're like 3. The only exception is the hazard diamond. You might need to look up the PowerPoint. Yeah, so we have red on top, yellow on the right, blue here, and then we usually have some symbol, and yes, this is going to be white. So red deals with fire, the white is some symbol, the yellow is reactivity, and blue is health hazard. So be able, if I give you a random hazard diamond, be able to tell me what dangers it represents. Intensive versus extensive. Intensive doesn't depend on size. Extensive does. So extensive is your mass, your volume, your length, and so on. Chemical versus physical. These include changes and properties. There's a few questions over that. So a physical property is something you can describe without altering it, such as color. You can look at something without changing it. But size too. Combustibility. The only way to know if something can catch on fire is if you actually go over and actually try to catch it on fire. So it'd be chemical. You would have to physically destroy your sample to determine its chemical property. Or is it corrosive? You would have to put it on something and see if it dissolves or reacts with it. A physical change, again, doesn't do anything to its substance. It stays the same. So liquid water going to solid ice. But the physical change is still water, still H2O. A chemical change would be like burning something. Precision versus accuracy. Precision. By the way, for people at home, code word is echo. Code word is echo. So precision deals with how close the values are together. So this is very precise. Whereas accuracy refers to how close you're actually to it. This would be very accurate. So how close your values are to the actual true thing you're trying to get. So the example I used in the last class, if you're striving to make 100 in the class, and you consistently turn everything in and make exactly a 30 on everything, on every test and every homework, you're very precise, not very accurate in your answering. However, if you turn in and make a 95, a 97, a 90, you're not very precise. Maybe occasionally a 85, 80, but you're in the ballpark of close to 100. You would be very accurate. If you want to be both accurate and precise, your values be very tightly together and around the true values. Be both precise and accurate. And neither. It's just randomly distributed around. So doing some examples. How many significant figures does this have? This has 4. If there's a decimal, we include trailing zeros. And we always ignore leading zeros. So everything between here and here. However, if I had written, so this has 4. If I had written 3400, there's no decimal. So we ignore the trailing zeros. It only has 2. So if it is 300.0, there's a decimal, so we include the trailing zeros. 4. And if I did 301, again, it'd be the first to last, so that'd be 3. If you had 260, there's no decimal, so we don't include the trailing zero. So this would have 2. However, if I had 2.60, because there's a decimal, we would include the trailing zero, so that's 3. And if we had 0.34, again, we always ignore leading zero. So we're going to. And if we had 1.010, because there's a decimal. So if there's a decimal, find the first non-zero and everything after is included. So 0.0001700. Again, find the first one if there's a decimal point. So you include everything after the first. Don't rub it against stuff. Also in multiplication, if we have 1.53 times 2, we choose the one with the lowest significant figures. So this would be equal to, trying to do this off the top of my head, that'd be 6, 10, that'd be 306. But because this has 1, we want to round this to one significant figure. And so we would round it to 3. Because we're very uncertain about this. Why do things float? Well, what if it's not floating in water? I didn't mention water. That's because it's less dense than the fluid it is in. So, do balloons float? What fluid do they float in? What fluid does balloon float in? No. What is air? Is air a fluid? Is air a fluid? No. It's mostly nitrogen. Air is about 80% nitrogen, 20% oxygen, and then there's like 5% other stuff. But is gases are gases considered fluids? What's the definition of a fluid? No. What is a fluid? If we say something is very fluid, what are you meaning by that? So ignore being liquid or whatever. If I say that the movement of this person is very fluid, they move very fluidly, we're saying that they flow, they're very smooth. A fluid is something that flows, is a rough definition. Air is considered a fluid. Have you ever felt the wind blow? You felt air flow past you, so air is a fluid. Fluids include both gases and liquids. So a balloon is floating in air because the balloon is less dense than the surrounding air. If I took ping pong ball if I took a cube and put it in alcohol and it floated to the top, that cube is less dense than the fluid it's in. The fluid in this case would be alcohol. So things float because they're less dense. Doing some density equations, remember that density is equal to mass divided by volume. So mass values, so mass units, this could be kilograms and grams, it can be milligrams, anything that measures mass. we usually always use the imperial system in chemistry. Volume units would be milliliters. Note that milliliters uses a capital L and lowercase m. We can also have liters. A milliliter is equal to a cubic centimeter. If we had like some sort of, not necessarily cube, but some rectangular shaped object, where we have a length, a height, and a width, the volume of this cube, or whatever you would call this, would be equal to height times length times width. If you remember from lab, that's how we measured the cube. Of course, for a perfect cube, we have all the sides being equal. So doing some examples. If the density of a 50-gram cube is 2 grams per milliliter, what is its volume? And let me make this 2.0. And let me make this 0.0 grams. So a 50.0 gram cube is the density of a 50.0 gram cube is 2.0 grams per milliliter. What is the volume of the cube? So our mass is 50.0 grams. Our density is 2.0 grams per milliliter. And our equation, density equals mass divided by volume. We're trying to solve for volume, so we need to put it in the numerator. Multiply both sides by volume, cancels that out on this side. Volume times density is equal to mass. We're still looking for volume, so we need to get rid of the density, so we divide both sides by density, cancels it out, and we're left with volume is equal to mass divided by density. Yes. Yes. So 50.0 grams divided by 2.0 grams per milliliter. Grams cancel out. Divide by milliliter flips the numerator, and that equals 25 milliliters. This test doesn't go include dimensional analysis, but if we were actually using dimensional analysis, 50.0 grams is 2.0 grams per 1 milliliter. This is how the milliliter flips the numerator. The grams cancel out in milliliters. And we put the answer as 2 significant figures, because this had 2, this had 3, and we choose the smallest. I would go back over the PowerPoints and your notes. Basically, it's going to be everything up to density was supposed to be the test. There's no scientific notation. But if you did have scientific notation, 2.00 times 10 to the 3. We just look at the number in front. This has 3 scientific notation. This has 3 significant figures. We ignore the times 10 to the 3. So, are there any questions? y'all think y'all got again, looking at what the test is mainly over, the test is mainly going to cover, I would say, well over half your test is going to be over density and significant figures. Make sure you get significant figures down, and make sure you can solve. You also need to memorize this equation. And there's just a few questions of other stuff. Again, some of the safety questions are very common sense. That should, well, that's all the test is going to be over. Is there any other questions? Well, that's it.